Okay, let's give you guys some practice. So come up with the position vector to describe this involute of a unit circle. So this is your involute, and this is your unit circle. Come up with the parametric equations or position vector to describe this path. Remember, if you can come up with the parametric equations, then you can always translate it to your position vector. Okay, so come up with the position vector. So what's happening here is that imagine you've got a circle here of radius 1, and you've got a string wrapped around this circle. So let's say this is the end of your string here. As you unwrap this string, remember the string is always taut. So this length here will always be the same as this length here, and it's always at a tangent to where you are. So suppose you're here. Then this will be the tangent, and then this length here will be the same as this length here. So let me illustrate this. Hang on. So you've got your unit circle here, and then as you unwound the string, it will follow that red path. It will follow the red path. So suppose you're here. Then you can see that the orange line is a tangent line to wherever you are. Suppose you're here, this orange line is really the tangent of that circle. So come up with the parametric equations or the position vector to describe this red path. Okay, so press pause and have a go. Okay, so to do this, we could use geometry. We could say, oh, let's call this angle here T, and this is 90 degrees. So this must be 90 degrees, take away T, and so on. We could eventually get to this point here by using geometry. But learn to use vectors is actually easier. It's easier on the mind. So let's try and use vectors. So the idea here is, well, we've got a vector to describe our position. So suppose we're here, this vector here will describe this vector here. So the idea is we are going to move along here, and then we're going to add this vector here. That will then take us to where we want to be, which would be this vector here. So our idea is to obtain this vector here. We would move along here, and then from here move along here. That will then take us to the same destination. Okay, so our usual routine, starting out with our position vector for this unit circle, differentiator, that will then give us our tangent, which will be in the direction of the motion. So the motion is in this direction. So our tangent line, our tangent here will be in this direction. But the thing is, we want it in this direction. But let's obtain the unit tangent. So we've got our tangent here, divided by its magnitude to obtain its unit tangent. So we want it of length 1. So to obtain our unit tangent, divided by the magnitude of our tangent. So the magnitude would be this thing squared plus this thing squared, cos squared t. You've got a minus here, so you can think of it like this. So this thing here would be 1, and then you square root it to obtain its magnitude, which will be 1. So our unit tangent would be this. So let's start again here. Let's go back to here. Starting out with our position vector for a circle, which is this thing here. If we differentiate it, that will then give us the tangent, but we want the unit tangent, so we divide it by its magnitude. Its magnitude happens to be 1. So our unit tangent would be this. So now our unit tangent, let's imagine our unit tangent to be this. But the thing is, we are going in the wrong direction. We want it to go in the opposite direction. So this is our unit tangent. The tangent for, I can't think of a good name, the tangent in reverse would be us sticking a scalar here, a -1. So let's start again here. This is our unit tangent, but it's going in the wrong direction. So stick a -1. That will then give us a unit tangent in the other direction. and then multiply this out, that will then give us this, and then let me think, and then so this is our unit tangent going in the reverse direction. Now we need to times by the length of this thing. What is the length of this thing? Well, the length of this thing is the same as the length of this thing. So remember, this is t. Hang on, let's imagine we've got a circle here. The whole thing here would be 2 pi r divided by, I know we're working in radians, but let me use degrees to illustrate my point. Divide into 360 equal pieces. So if after 1 second you would have moved 1 degree, after 2 seconds you would have moved another degree. So the time coincides with the angle. So well, we've done this many times, so I hope you can accept that this length here is also t, because let's say this circle here is of radius radius 1 in our case. So the whole circumference here will be 2 pi r, which is 1, divided into 2 pi equal pieces, just like this thing here, and then after so 1 second, 2 seconds, 3, you would times by 3. So here we would times by t. So this thing here is 1. Well, I hope you can accept that this length here is t, because we deliberately create t to coincide with our angle. Well, anyway, this length here is t. So let's start again. We've got a tangent. Stick a -1, that will go in the opposite direction. And then now we need to times by the magnitude of this thing here. Well, the magnitude is the magnitude of this thing here is the same as this thing here, which is t. So we hang on, let me think. So this is our unit tangent. Hang on. This is our unit tangent going in the opposite direction. But now we want to times t, because we know this length here is t. So times t. This times this will then give us this. This times this will then give us this thing here. So let's call this orange vector here. Orange vector here. Well, the orange vector is given by that. So if we want to get from here to here, we would move along here, which is given by this, and then we would add it to this orange vector. We would add it to this orange vector. So we would travel along here, which is given by this, which is this thing here, and then we would add it to the orange vector here, which is this thing here, which is this thing here. Okay, well, anyway, our final vector, which is this thing here, is given by this plus this, which is this plus this. So your final answer is, well, if you get the x component added to this, and then this added to this, that will then give you this. And then if you're working in parametric form, you can say that, x equals this thing here, y equals this thing here, same thing. Okay, so play around with Desmos. Load up Desmos, desmos.com, and then punch in all these things here. Punch in all these things here, and then that will then give you this thing over here. And then you can slide A, and then as you slide A, it will animate the path. Okay.